Okay, so I'm going to do the Archimedes method. And first we start with turning on our scale. We want to make sure that it reads 0, 0, which it does. Now we're going to place our metal bolt on the scale to get its mass, which is showing 8.0. So we're going to go ahead and record that in our data table. Okay, now we're going to attach string to the end of the bolt. Okay, like so. Okay, and then we're going to fill our glass beaker about 3/4 of the way full with distilled water. So I have that just right barely above 75 milliliters. Okay. We're going to place this on the scale. Okay. And then we're going to turn it off and back on so that the scale zeroes out with the beaker on it. That way we can figure out the mass of the displaced water. Okay, then we're going to submerge the bolt. We do not want it touching any sides or bottom. Okay, and it's showing 1.1. Go ahead and take that out. And you record that in the mass of the displaced water. Okay, and now we're going to convert the mass to volume, and we're going to assume that the density is 1 gram per milliliter, which is the density of water. So we're going to do 1.1 divided by 1, which gives me 1.1, and that's going to be in milliliters. Okay. Okay, then we're going to calculate the density of the bolt using the volume we just found and the mass of the bolt. So we're going to do 8 divided by 1.1, and that gives us, let's see, 7.272727, but with the right amount of significant figures, we're going to do 7.3. Okay, and that's grams per milliliter. Now, we're going to untie the bolt. Set that aside. Take the beaker off. Now we're going to get the mass of the magnet. We're going to make sure the scale is at 0, 0. It's coming up 4.6, so we will record that in our data table. Now we're going to tie the string onto the magnet. Now we're going to put the beaker back on. And we're going to adjust the scale so that it comes to 0, 0. And now we're going to submerge the magnet, and remember, not touching any walls or the bottom. and it's showing 0.9. So go ahead and take that out. So the mass of displaced water is 0.9. Okay, and then we're going to find the volume the same way we did with the other, with the volt. So we're going to do 0.9 divided by 1, which is 0.9. So as you can see, the mass and the volume of the displaced water is the same, approximately. Okay, and then we're going to find the density of the magnet, which we will do by dividing up 4.6 by 0.9, and that gives us 5.11111. So if we write sig figs, we do 5.1. Okay, take that off. Turn this off. And we are done with Archimedes' method.